All right, today's lesson, exercise 4G, we're going to review area notes. Now, very similar to the conversion chart for lengths, there is a difference when we're converting squared kilometers. Notice the language I'm using. I didn't say kilometers squared, and I didn't say meters squared. It is squared kilometers, squared meters, squared centimeters, and squared millimeters. The reason why I'm emphasizing that is because that's the language you use out in the real world. When you're buying a house, they do not say your house has, or the land is 700 meters squared. They will say squared meters, or they'll use another word for only for lands and building. They call it squares. Out of curiosity, does anyone know what 1 square is equal to in squared meters? It's just a sort of fun fact. If you're buying a house, you'll know. An average house has 24 squares, which means most of your houses, when you're going in, and if you had to calculate the area and break up your rooms and all that, on average, it's about 24 squares. Anyone have a clue?
10 square meters?
Well, that's pretty close. It's 9. 1 square is equivalent to 9 square meters. Now, if you think about it, 9 square meters, if I drew a square, to get 9 squared meters, what should the length be? 3. Most of your rooms, in general, an average room, is about 3 meters by 3 meters. So if you think about your room, if you can do about 3 steps up and then 3 steps across, that's your average room size. But your master bedroom, check out your parents' room, I'm pretty sure most times it is larger than 9 squared meters. Okay, they're usually about a 4 by 5, maybe 4 by 4, something like that. Sometimes 4 by 3. But if you have a plan of your own home, if you added them, most of it roughly is about 24 squares. So this is the language they use out in the real world when you're buying stuff. So when they're selling you homes, it gets confusing between talking about my land or the house. My land has 700 square meters versus my house has 24 squares. Okay, so that's just a fun fact to add on. But the thing that I really want to teach, though, is whilst most of the things are similar, from meters to kilometers, we know that there is 1,000. 1,000 meters makes a kilometer. But notice that when we're doing area, they also add on a square. Volume, they'll add on a cube. Now you can memorize that. I remember asking my engineering cousin about this conversion. I was asking him, do you know how to convert, from squared, from area squared to another squared? And he's like, yes, you times by 1,000. And I'm like, no. And the reason why I knew that he didn't know is because a lot of students memorize this. Okay, so even though he's in engineering, he knows his maths really well. It's just the fact that he doesn't apply this as often, because most times in real life, you do your own, there's programs that does it for you. But does anyone know why? Why is it 1,000 squared? So for lengths, if you want to convert 1,000 meters to kilometers, we say from 1,000, you need to divide by 1,000 to get 1 kilometer. So 1,000 meters equals 1 kilometer. But then why is it when you're converting, say, 1,000 squared meters, and then you want to convert that into squared kilometers, why do you have to divide it by 1,000 squared? Anyone have a clue? All right. On the side of your sheet, I gave you a picture so that you can visualize what this means. Let's do this. So imagine you had a room. Actually, it can't even be a room, but if you had a space that was 1 meter by 1 meter, which usually is about a closet. So your closet might be about 1 meter by 1 meter, or one of those closets over there is about a meter by a meter. That space, if it was a square, what's the lengths? What will the lengths be? A meter. So this is 1 meter, this is 1 meter. So you would tell me that the area is equal to 1 times 1, and that gives you 1 squared meter. True? If I asked you now, just from what you understand from 4E, what is 1 meter as centimeters? How many centimeters make 1 meter? 100. So another way of writing this is I can have, instead of 1 meter, I can write 100 centimeters here, 100 centimeters there. Should be equivalent. But if I asked you to find the area in terms of squared centimeters, you would have said it's 100 times 100. And 100 times 100, another way of thinking about it is 100 squared. So when I ask you to convert squared meters to squared centimeters, can you see you're still timesing that 100, but because there's actually two dimensions. You times this one to convert lengths, you timesed it by 100. Then you also had a second dimension because area has two dimensions. Volume has three dimensions. Length only has one dimension. Does that make sense? So one dimension was only one time that you multiply by 100. Area, you times it twice. That's why it ends up being squared. Why is it volume that it becomes cubes? Because your volume, if you did a volume exercise, the chart's still the same, except it's cube. And then the reason for that is if you drew a cube, it makes a lot of sense. So a cube, same thing. If I called it meter by meter, 1 meter, 1 meter, 1 meter, you convert them all by 100, 100, 100, you're timesing it by 3 times. So hence why it's 100 cubed. Make sense? All right, so that's the logic for it. So either you memorize the chart, or if you understand it logically, you can always derive it yourself. Okay? Now, let's write some formulas. Let's see if you remember what's from year 7 all the way to year 8. Well, advanced group probably would have learnt in year 7 already. Let's write all the formulas that we know. Area of a square, which we just did just now. Lengths are all the same, so it'll be length times length, or L squared. What's the area for a rectangle? Can I please have Joanne? Length times width. Beautiful. If you didn't realize up until this point, because we're talking about 2 dimensions, area is about 2 dimensions, right? So they have to be perpendicular with each other. You're always multiplying the lengths that are perpendicular. Notice all the formulas I'm going to show you now, they're all multiplying when it's perpendicular. So that's perpendicular. So width and length are perpendicular. It's length by width. Let's have a look at the area of a triangle. What's the area of a triangle? Can I please have Sunny? Very good. And notice again, base and height are perpendicular. It's always perpendicular. We're always looking for the 2 dimensions because that's what area represents, right? The space in 2 dimension. So you got half times base times height. Very good. Rhombus. Anyone remember the area of a rhombus? What's the area formula for a rhombus? The diagram kind of gives you a hint. Hands up if you know. Anyone know? Not sure? It is half the diagonal 1 times diagonal 2. That's why they've drawn the diagram with y being the diagonal here and x is the diagonal this way. Okay? So half of diagonal 1 times diagonal 2. What's confusing is, and you can prove that as well if you actually split it up into 2 triangles. So cut it like that and use the perpendicular, because the intersection between the 2 diagonals is actually 90 degrees. And so remember I said area is always related to the 90-degree point. So that 90-degree point, if you split up the 2 triangles and you found the area of this and then the area of that, then you'll find that the proof ends up being half d1 times d2. Okay? Anyways, the reason why I thought it was interesting is because rhombus and a parallelogram look very similar, but the formulas are different. So rhombus, all sides are the same, and that's why you end up with a 90-degree intersection. But a parallelogram, not always do you get a 90-degree intersection. So, anyone remember, what's the formula for a parallelogram? A is equal to what? Hands up if you know. Raha. No, that's trapezium. Yes, this is base times height, but not over 2. Yeah, this is where it's confusing. So this one, remember I told you it is the perpendicular lines? Here's your height. Here's your base. Arguably, because it's parallel, this triangle here actually fits perfectly right there. Because that's 90 degrees. That's going to be 90 degrees. This hypotenuse is exactly the same length as this hypotenuse. And so hence you can actually match it over here. And if you did, it's height by base. So hence, it's like a rectangle. Yeah? So I'll just delete that. And so usually the diagrams kind of give you a hint to remind you what the formula is. It's base times height. What about trapezium we already had just now? It was area is equal to half times A plus B times the height. And A and B, remember, it is representing your two pairs of parallel lines there. So I'll highlight there, A plus B. What about a kite? What's the area formula for a kite? Whoops. Yes, there is an X times Y. And it's over 2. I know, this is so confusing. Rhombus and a kite actually works out the same. And again, it's about where the 90 degree is. That 90 degree part. And very similar to a rhombus, because the 90 degree intersection, you can actually cut this up into 2 triangles. And the same thing, find the area of this triangle, find the area of this triangle, and you combine it together. You'll find that's how they get that. Okay? And your last one. What's this shape called? There's a special name for it. Sector. Very good. Sector is just a partial circle. What is the area formula for a partial circle? Let's go with Sean. Beautiful. Pi r squared is for a full circle. Oh, yeah. Pi r squared is for a full circle, and theta is your angle. So when you have partial circle, it means out of 360, you've got a part of it. So you take a proportion of your full circle. Those are the formulas for the things that you need for today's lesson. Okay, so you'll likely get shapes that look like that. You get shapes that are composite shapes, and then you're meant to break them up and solve and problem solve. Easy? Let's do a couple of problems together. Flip over the next page. All right, let's do a conversion. How do I convert 3.5 squared meters, remember the language is squared meters, not meter squared, to squared centimeters? What do we do? Jaden? Times by? 100 squared. Very good. So, remember, if you forget the squared bit, just figure out the meters to centimeters. And we know that 1 meter has 100 centimeters, so you have to times that. So it is times by 100 normally, but because it's area units, it's 100 squared. 100 squared is the same thing as saying 100 times 100, which is 10,000, because there's 4 zeros there. So what is 3.5 times 10,000? What does that equal to? Can I please have, let's go with Olivia. What's 3.5 times 10,000? Very good, 35,000. And the way I do it is I just think 3.5 times by 10, so just 1 zero off, and that's 35. So you add on another 3 zeros. Okay, so that becomes 35,000 squared centimeters. Let's do the next one. How do I convert 50,000 squared millimeters to squared meters? Sunny.
So you got times like times 1,000 squared.
Oh.
10,000 squared.
Oh.
100,000 squared.
And do it slowly. So sometimes, and this is where it's confusing. Without the chart in front of you, you got to pick a number that you generally know. See, one fact that we know is how many millimeters make 1 centimeter? 10. But to go from 10 to centimeters, do you times or do you divide? Divide, because from 10 to get to 1, you have to divide. So that's why if you go to meters, it's actually counterintuitive. It's the other way around, you divide. So now that we know, so we divide by 10 to get to centimeters, but then we then need to divide by 100 to get to meters. So together, you are dividing by 10 with another 2 zeros is 1,000, but because it's area units, it's 1,000 squared. Make sense? All right. 1,000 squared is actually the same thing as saying 1,000 add on another 3 zeros, which means you are taking 50,000 and you're dividing it by 1, 2, 3, and you're squaring it, so there's another 3 zeros. It's a million. Okay, so 1,000 squared is a million. Just add on the zeros. So you got 6 zeros that you got to go backwards from. So 50,000 has 1, 2, 3, 4. 4 zeros. So you go back 1, 2, 3, 4, 5, and then 6. So what would my answer be? Can you visualize it? What's my answer? Yes, Sanvi. Beautiful. Squared meters. I know. It's the way we read it, left to right. That's why. But it's good for, when you say it right, someone out there who's a mathematician will know. And those real estate agents, they'll be like, you must be a maths person. All right, so let's have a look at the next one. The area of the composite shape shown, leave answers in exact value. This means don't change it to decimals. Okay? Let's do this one. A, this is clearly a sector. We know the area of a sector is theta over 360 times pi times the radius squared. What is my radius here? Let's go with Mira. 2, very good. This says here, from here to here is 2, so that's my radius. So I know that radius is 2. What is the angle that I'm looking for this partial circle? Yes, Mira? Very good. Some students will say 100. It's not 100 because 100 makes this smaller sector. We want the larger sector, which is actually known as the major sector. So the minor is the smaller one, major is the larger one. So we know this one has to be 260 degrees. Therefore, it's 260 out of 360 is the proportion we want, times pi, times the radius, which is 2 squared. All right, let's simplify now. 260 over 360 is the same thing as saying 26 on 36 times 4 pi. 26 over 36 times 4 pi can be reduced to? Oh, that's right. I was going to do the 4 and the 36, but that's true. You said 13 over?
0.72 times pi times 4.
How'd you get 0.72?
I divided 26 by 36.
Oh, don't change it to decimals, although it is technically an exact value. Most the answers that later on the senior levels want is you want to keep it in fractions. Okay, so one of the easier ways is, yes, you can simplify 26 on 36 by halving it. If you divide both top and bottom by 2, you now get 13 over, what's 36 divided by 2? Is that 18? 18? No. Yes, it is 18. 18 times 4 pi, but we can still reduce this down. What 2 numbers can I reduce? Think about it when you're multiplying, I can write it as a fraction. There's 2 more numbers that I can see. There's a common factor. 4 and 18. 4 and 18 has a common factor of 2, so I can say 2 goes into both, and that gives me now 13 times the 2 pi over 1, and 18 divided by 2 is 9, and now they don't have any more common factors. So as an exact answer, 13 times 2 is 26 pi, and then 9 times 1 is 9. This is the preferred answer that they would want you to leave at the end of year 11 and 12 when they say exact value. Okay, you never write a decimal in a fraction, and you never write a fraction within a decimal. Okay? 26 pi on 9 is your exact answer, but I am not finished. If I left this in year 12, I'd lose a mark. Why? Not centimeters squared, it's called? Squared centimeters, very good. So don't forget the units, it is squared centimeters. Very good, next one. So that was a straightforward sector, straightforward formula use. So we've got a formula, here's the approach. Notice the way I lay it out. Approach, question method, answer. Okay? Let's look at the second one. This is a bit of a problem-solving one now. This one is not a shape that we know, but there are parts of it that we can extrapolate or take out. What 2 shapes can you see? Andrea? Beautiful. So if I cut this one through, that's a semicircle right here. Semicircle. And then if I colored this big shape overall, it's a rectangle. So the area that I want, which I'll color in red, is this section. So it means that if I got the rectangle, which is in blue, larger area, take away the yellow area, I should get the red area. So hence you would say area is equal to rectangle, take away the area of a semicircle. Rectangle is length times width, whilst semicircle, which we already know is half times pi r squared. Length by width is 6 times 10, or I should write it properly, it should be 10 by 6. Usually when you say length, that's the longer side. Minus half times pi times the radius. Now what is the radius in this particular case? Yes, Mira? 3, because we know the diameter from here to here is 6. We want the radius. Radius is halfway. So from this center all the way up, that's a radius. So radius must be half of 6. That's why it's 3. Okay, so this section from here to here is 3. That's 3. So 3 plus 3 gives you the length of 6. Okay, so now I know this must be then 3 squared. Now we can plug it all in and simplify and solve. Here we go. 10 times 6 is 60 minus, technically this is half times pi times 9, which you can write as 60 minus 9 over 2 pi. Hopefully I didn't speed up too much there in fractions. If you wrote them all as a fraction, his denominator is 1. So 9 times pi times 1 is 9 pi, and then 2's on the bottom. Or 9 twos, 9 halves of pi. Now in year 12, my year 12s don't like this as well, but most answers, they prefer not in 2 terms, they prefer it in 1 term. This is considered 2 terms. You've got 60 and that. So they prefer it as one big number. How do we combine these 2 numbers? What's 60 minus 9 over 2 pi? Yes. Beautiful. So change the 60 to a fraction. It's 60 over 1. You need denominators to be the same, so you times both bottom and top by 2. And so now you have 120 take away 9 pi all over 2. That is the preferred answer in the senior level. Sometimes you get penalized, sometimes you don't in the exam. Just depends on the distribution that year, whether they want to penalize you or not. Okay, so it's better to just do it that way. You just won't get it wrong. Okay, so 120 minus 9 pi on 2. Again, I'm not done. What am I missing? 9 meters squared. Squared meters. Very good. Yes, I'm doing it very purposefully, that I keep nagging you on it because I know it's easy to forget on how to pronounce and forget your units. Make sure your units are clear and it's there. There we go. So I got an approach, method, answer with my units. Last question for today. Correct into 2 decimal places. This is pretty straightforward, but let's see. What shape do we have in A? Can I please have, let's go with Michelle. What type of shape is this? Rhombus. How did you know it was a rhombus though? It's got
4 parallel, not parallel, but all ends are the same.
Good. They got these dashes here, the double dashes, and that implies that all 4 lengths are the same. If it's all the same and it's clearly not 90 degrees, it's not a square, it has to be a rhombus. So this is a rhombus. What was the formula for a rhombus again, Toby?
It was half of diagonal 1 times diagonal 2.
Good. So in this case, it'll just be half times 10 times 15. Plug it in your calculator because it says to round to 2 decimal places. That's essentially what 10 times 15 is 150 and then divided by 2. 150 divided by 2 is 75 squared centimeters. I guess there's no 2 decimal places. Sometimes, I did ask Mr. Berger about this. In the past, I used to make my students write 0.00 squared centimeters at year 11 and 12. But I heard that they do not penalize you now, so you're okay. So sometimes if they say to 2 decimal places, when I first was taught by a senior person in my first year of teaching year 12s, they told me that students had to put 0.00, if not they lose a mark. I think they've been lenient over the years, so they've just taken it off. Okay, so apparently 75.00 or 75 is still acceptable. Okay, Next one, B. What shape do I have in B? Let's go with Rowan. Oh, Rowan's not here. I'm just going through all the names in my head. Rowan's not here. Who's the next person then? I haven't checked. Oh, yes, Andrea. It is a parallelogram. Looks like a rectangle but on a side. Parallelogram. What was the formula for a parallelogram? Let's go with Sahad. Very good. Base times height. And it's kind of given a clue because that's where the 90 degrees is. So hence, it must then be 1.37 times 0.82. I have no idea what that answer is. Anyone got a calculator? Yes. 1.122. 234. Okay. Anyone else confirm that that's correct? Yes, hands up if it's all correct. Good. All right, we can trust it. And because it says round to 2 decimal places, this is equal to what? What's this rounded to 2 decimal places? Let's go. Who am I chosen? Cassidy. Very good. 1.12. Don't forget the units. Squared meters. Very good. Okay. That's it for today. So you get a bit of problem solving, a bit of direct formula use. The later questions are more problem solving and reasoning. Okay. I'm going to stop there. That's it for today. Now, just as a reminder, homework, make sure to submit. So we are now starting to get back into rhythm. What you were missing from last time, because last time you only submitted, I was only looking for one, but whatever you're missing from last week is going to be added on. Okay. But where do I want up to? At bare minimum, just up to Monday. If you've done at least Monday's one and last week's, whatever you're missing from before, that's what I want, minimum. Okay, because then you're going to catch up. So here's your planner just to help you remember. Here's your planner. So this is what we've done so far in term 1. We had a lot of interruptions. So I told you I only expected 4A. Yeah. And then I asked you what we are now in week 3. I've done 4E, F, G. I just expect these plus E. So if you haven't done these ones, that was what you were meant to do last week to catch up. It wasn't due, but I expected you to put in the time and effort. Okay, so up to E. That's my expectation. So pretty much A, B, C, D, E, minimum. If you've done the rest, great. Okay, so by next week, we should be back on track, and we should be on time. One more thing as well next week, because it's only 2 exercises. On the Monday, when I have you, I'm going to give you a progress quiz, because your progress reports are due next week for me. So I got to write some updates on how you've been doing in the chapters. It is only on SIRS. Okay. So that's most recent. Everything to do with SIRS. Nothing to do with the links yet, just the SIRS. It's a progress quiz. Should take you about maybe 20 minutes. 15, 20 maybe. It's only double-sided. That's on Monday. So prepare. So make sure you've done 4 A, B, C, D, E, or at least 4 A, B, C, D. Then you'll be ready for progress quiz. I'll get you to write a reflection on the Monday as well, and then I'll write some comments after I check your work. Give me a second, I'm just going to stop the video.